feel free to send me an email and I'll definitely get you an answer back. And then the other thing I want to point out is if you're interested in trying out Pluralsight, just send an email to my boss, Paul Randall, and he'll send you a code that you can use for 30 days of Pluralsight. And that doesn't require a credit card or anything. So make Paul do some work and send him an email. Just say user group and ask for a Pluralsight code. So just jumping into this, what we're going to be talking about is what are the most common causes of downtime and data loss? And then how do you go about planning a high availability strategy? And then what are some of the high availability technologies that SQL Server 2014 has included as part of the product? And then how do you go about planning a disaster recovery strategy? And what are some of the disaster recovery methods that you can use with SQL Server 2014? So what is high availability? Well, basically it just means that you have something that is able to be used as expected no matter what little things might happen to prevent that from occurring. So for example, you've got a back-end database that's behind your website and that's available to service the transactions from the website, no matter what else might be going on, the things that you do to make sure that you're not actually just down. And high availability means that you have done something to protect that database server from becoming unavailable. And there's lots of different technologies available to do that with, and you don't have to pick just one technology, that you can combine them. And we'll talk more about how you go about choosing the best technology. You don't just say, well, I'm going to use failover clustering. That's not how you go about it. You want to start talking about what's called your RPO, your recovery point objective, and RTO, your recovery time objective. So anyways, the users and the applications that are using your database servers have to always be able to do what they have to get their job done. And so what is this something that we're trying to protect? Well, it's going to vary by the situation. So maybe you're trying to protect an individual table in your database. And if that's the case, you can use something as simple as transactional replication, or you can use something that protects the entire database that also ends up protecting that individual table. And maybe that you have a group of databases that have to be together and they all have to be on the same server and all up. So in that case, you could use an always on availability group if you have SQL Server 2012 Enterprise Edition or newer. It could be that you're trying to protect an entire server or an entire instance of SQL Server. And if that's the case, traditional old-fashioned failover clustering works quite well as long as you're able to live with some of the downsides of that, such as having a single point of failure for your shared storage and the relatively long failover time that you get with traditional failover clustering. And it may be that you're needing to protect the entire data center from failure. So you might use something like SAN level replication, or there's some other things you can do at the SQL Server level. So again, you need to think about what is it you're trying to protect and what is the most important thing to you and your users. Now, the causes of downtime and data loss, you have planned downtime, which typically doesn't always count against your SLA agreement, or you have unplanned downtime, unexpected things that causes downtime. So the main reasons for planned downtime are performing database maintenance. That's one of the main reasons you have planned downtime, especially if you are stuck with SQL Server Standard Edition that doesn't have online index operations. So simple things like creating or rebuilding a non-clustered index or a clustered index can cause you to have to take a maintenance window because you just can't do that with a larger table with SQL Server Standard Edition. And that's one of the main reasons that a lot of organizations spring for Enterprise Edition, just to get online index operations. And if you are going to use Enterprise Edition and use online index operations, it's really important that you go about it in the correct way and you actually specify online equals on when you do something with an index. And it's also really important to set max DOP equal to 1 when you're building or rebuilding an index, because if you don't do that, you have the potential to really cause a lot of performance impact on your infrastructure. And also the index that gets built or rebuilt has a lot more fragmentation if you don't use max stop equals 1. So that's something that a lot of people don't think about. Another thing that causes a lot of problems is doing batch operations, so if you want to go in and try to delete 5 million rows from a table, well, the right way to do it from an academic point of view is to use a set-based operation, just delete all those 5 million rows in one shot. But if you do that, that's going to cause lock escalation and table locks and cause problems. So you might have to think about doing it differently, nibbling it away at and take a few thousand rows at a time, which takes longer and creates more work, but it doesn't cause downtime. Another thing that's very common problem that might cause planned downtime is actually installing a SQL Server Service Pack or cumulative update. And I've always been a big proponent of trying to stay up to date with cumulative updates. And for quite a while, there was always a lot of debate in the SQL Server community about whether or not that's a good idea or not. But finally, just recently, after many years of arguing, Microsoft has changed their official policy and language on their knowledge base articles for cumulative updates. So they've removed all the scary language about cumulative updates not being fully tested, and they're actually advising people to stay up to date with their cumulative updates. And doing that forces you to get in the mindset of doing regular maintenance to keep your SQL Server instances up to date, and having a plan for how you go about testing everything and how you roll out this update and how you would roll it back if you ever had a problem is really good for your organization, and it gets you in the mindset of not being afraid to touch your SQL Server instance. I've seen so many DBAs over the years where they install SQL Server and then things are running on it and they're almost afraid to touch it because they might break something. So I find all these SQL Server instances that have really, really old builds of SQL Server for whatever version they're running, and they often run into many problems that were solved in later builds of SQL Server. So I guess I'll get off my soapbox about that, but I think staying up to date is important. But of course, when you do apply these maintenance updates, you're going to take some downtime, and you can reduce that with some of the HA technologies we'll talk about later. Another common reason is, installing the Windows or Microsoft updates that come out every month, and then also keeping up to date with your drivers and your firmware on your server. And then, you can use rolling upgrades to minimize your planned downtime if you have the right HA technology in place. So if you have a standalone server and you want to reboot that server, if it's not a VM, you might be down 20, 30, 40 minutes for that server to reboot and come all the way back up. Whereas if you've got something in place like failover clustering or database mirroring or an always-on availability group, you can use a rolling upgrade so that your actual downtime is much, much shorter. So reasons for unplanned downtime. Well, depending on where you live, what part of the world, you have different kinds of things that might happen to an entire data center. Different kinds of natural disasters like earthquakes or flooding or fire. You might lose power for an extended period. You might have somebody have a backhoe dig through a network cable so the entire data center loses network connectivity. And most good data centers have, redundant cables coming in, so that's not an issue. Another thing that might happen, although it doesn't happen as often as it used to, is an entire server might fail. An individual component like a power supply or a processor or some memory might have a problem, or the entire Windows operating system might crash, but that really doesn't happen as often as it used to. Newer versions of Windows are much more stable than they used to be, and that just is not as big an issue as it used to be. Another thing that's somewhat more common is some sort of an I/O subsystem failure. So an individual drive might fail, but hopefully you've got the appropriate level of RAID so that an individual drive failure doesn't bring you down. The entire RAID controller might fail. You might have some problem with your I/O subsystem driver or other things that cause a problem, whether it's corruption or an actual crash. But probably the most common thing that happens is some sort of human error. So somebody accidentally drops a table, or they delete or update a bunch of data without having a where clause. That's a very common thing that happens in real life. or setting a database offline, or accidentally shutting down a SQL Server instance when they didn't mean to. And one of the most common things that happens is, a typical DBA has got SQL Server Management Studio open, and they've got connections to production, they've got a connection to staging and to development, and they think they're connected to development, but they're actually connected to production, and they do something they didn't mean to do, and then you've got a problem that you've got to recover from one way or another. So planning a high availability strategy, the very first thing you should do is not just say, well, I want to use always on availability groups because that's the latest and greatest feature from Microsoft. That's the backwards way to think about it. What you want to do is talk to the business. You don't want to make this up yourself, and talk to the business and find out what their recovery point objective is, RPO. And that just means the maximum allowable data loss in terms of time when a failure occurs. And of course, if you go and ask the business, well, how much data can you afford to lose? They're going to say, none. We don't want to lose any data. And what you need to do is, try to find out if they're really serious about that. And if they are, then come up with a plan and a budget to try to meet that. And then quite often they'll change their tune and say, okay, wait a minute. Maybe we can afford to lose 5 minutes or 10 minutes worth of data. And that's a much more achievable RPO at a reasonable budget and a reasonable level of infrastructure. So you need to go through this and come up with a formal RPO, because if you don't do that, the business is going to assume that it's zero. Hey, it's SQL Server, and we've got Glenn Berry as a DBA, so how could we possibly lose any data? And that's an incorrect assumption on their part that they're going to have if you don't do something about it. The other key thing to think about and get an agreement on is your recovery time objective. And that is, how long will it take you to come back online when a given type of failure occurs? And that's going to be different for different types of failures. If you lose your entire data center and all the hardware in it, unless you have another data center standing by, it's going to take you much longer than if you just do something that's much more minor, like the OS crashes. So different things are going to have different RTO requirements, and you need to think about what you think is the most likely and come up with a plan and an agreement that meets those RTO goals. And then the other thing you need to think about when you're building these and coming to an agreement with the business is unplanned downtime is all you worry about, or does it have to include planned and unplanned when you're trying to come up with an SLA for your total uptime for the year? So here's just a little chart that shows you, people talk about, 3 nines and 4 nines and 5 nines availability. So if you're talking 5 nines availability, that just gives you 5.26 minutes of downtime for the entire year. And that's really hard to meet that, especially if you have to count planned downtime in that figure. If planned downtime doesn't go into that, then it's quite a bit easier. But even so, 5.26 minutes for an entire year of allowable downtime is pretty hard to do. So just for your reference, here's how much downtime you're allowed with these different levels of availability. Now, SQL Server 2014 has several HA-related technologies built into the product. So, one thing you should always be doing, no matter what else you're doing or whatever fancy product that somebody has sold you, is make sure you've got an effective backup and restore policy in place, and you actually test your restores on a regular basis, because if everything else you do fails, you've got backups, hopefully, and you know that when you restore those backups that the restore is going to work, and you should actually be testing those. And unfortunately, Paul Randall helped write DBCC CheckDB when he worked at Microsoft. And so he's known as sort of a corruption fixing expert. And seriously, about every week we get 2 or 3 emails from some frantic DBA who says, well, we have a corruption in our database, and DBCC CheckDB says that the only option is repair allowed data loss, and we tried restoring our backup and it doesn't work, and please help us, Paul. And sometimes Paul can help them and charge them a lot of money, and sometimes he can't. And we've seen companies go out of business because they don't have a viable backup and their production database is corrupted. So make sure that doesn't happen to you no matter what else you do. But also, Component redundancy, basic component redundancy on your database server is something that gets ignored far too often. And then beyond those two basic things, then we have Windows failover clustering, which has been around forever and still works the same as it always has, and it's very familiar to IT staffs, and it's very easy to implement and manage. You've got always-on availability groups that was added in SQL Server 2012, and it requires Enterprise Edition and has a lot of other things you've got to do to make it work. But once you get it in place, it can be an effective solution. We've got database mirroring, which has been around since SQL Server 2005. It's deprecated now, but it still works just fine, even in SQL Server 2016. And it can be a good solution in some cases, even though it's deprecated. Don't be afraid of it. Transactional replication can be used for some HA purposes. And then peer-to-peer replication, which is enterprise only, and it's still there, but it's a little more complicated to set up and use. And then you've got log shipping, which has been around forever, but it's more of a DR technology than an HA technology. So backup and restore methods. Make sure that you're not that typical accidental DBA who doesn't understand the different recovery models, full, bulk logged, and simple. One of the most common things that the accidental DBA does is they somehow manage to install SQL Server, and they somehow manage to create a database for this payroll application their company bought, but they don't even know what a recovery model is. So it's running in full recovery model, and everything works fine for like 6 months until they run out of disk space on their C drive because they have a runaway transaction log. Don't let that happen to you. And once you know what your RPO goal is, then that'll help you figure out what recovery model you need to use, and then how often you're going to run your backups. And so, it's really important that you think about this and don't just sort of do it on the fly. And in most cases, you're going to want to use a combination of full backups and differential backups and log backups. And think about this so that you can try to meet your RTO goal, so that if you do have a problem and you've got to go through and restore all your backups, you can do it as quickly as possible. And a lot of DBAs that I talk to don't ever even think about using differential backups. And so they'll do something like a full backup once a week and then log backups every 15 minutes. And if they have to restore towards the end of the week, they got to restore a lot of log backups, and that takes a lot more time to do. Nothing that I see a lot of people not doing is not using backup compression and not using backup checksums. That's a default setting you can do in SQL Server 2014 at the instance level, so that all your backups use backup compression and backup checksums. And that'll make it more likely that your backup is good. You still don't know for sure until you actually restore it, but at least you have a little bit better confidence that the backup's going to be good if you use backup checksums. Another thing that people don't do that often, which is an enterprise-only feature, is use mirrored backups, where you can run a backup to 2 different locations simultaneously, so you've got 2 copies of the backup. Of course, people always talk about the backup strategy, but they sometimes don't talk about the recovery strategy. So you actually need to go to the work of testing, restoring your backups, and have a plan for how you would do it. And the most senior person can come up with a plan, but you want to make sure the most junior person in your organization can actually do it and make them do it in a practice setting. And making sure that you have instant file initialization enabled for the instance and using backup compression has a huge effect on how long it takes to do a restore. And also keeping your VLF counts on your log files under control reduces the recovery portion time of a restore. So if you ever watched a large database restore and you've got it set to update every 1%, and it gets all the way to 100%, and you're thinking, okay, great, it's done now. And then you see it grinding away for another 15 or 20 minutes or longer. That's because it's going through the recovery portion of the restore, and that's taking much longer than it needs to because you have a really high VLF count. And keeping the VLF count under control is really important for that reason and some other reasons. So what I have a lot of customers doing is using a secondary restore server. So what you do is you have maybe a copy-only backup go directly to a file share on this other server, And then you have that server using a job to restore each database every day on that test server to make sure that it actually restores. And then once you've done it on that other server, then you can run dbcc check db on that other server, and that way you can take the load of running it on your production server and move it to a different server. And if you run into a problem on that test server, then you can go ahead and run it on the production server. But that's one way that you can make sure that you're actually regularly testing your restores and also regularly running dbcc check db if you're worried about the impact on your production server. And this is really easy to automate through just some simple SQL agent jobs. You can even have Ola Hallengren's stuff do most of the work to do all this. So it's a really good solution. And you can just use a desktop machine with some decent storage on it to do this if you are budget constrained. So another thing that people don't always think about enough, in my opinion, is just basic component redundancy in your database server. I've had a lot of people who their organization is hesitant to spend that small amount of extra money to get redundant components. And you're just trying to eliminate every single point of failure that you can at the hardware level. So multiple power supplies plugged into separate circuits. So if one of the circuits trips or one of the power supplies fails, the server doesn't go down for just a silly reason like that. Having multiple network ports that are plugged into separate network switches, having an appropriate level of RAID protection for all of your logical drives. But don't think that RAID is going to protect you from everything. All it's doing is trying to protect you from going down just from losing one or two hard drives. And then having hot swappable components in your server. And most rack-mounted servers are going to have all these things, but if your organization is using tower servers, often you won't have hot swappable components. And then finally, try to have some cold spares available. So if you've got a bunch of Dell R730 servers in your data center, you might want to have one or two extra hard drives or SSDs that you use just sitting there in the cage so that if you have a failure, you can go ahead and replace it right now and then worry about RMAing the failed drive instead of having to wait until the new replacement shows up before you rebuild your RAID array. So that's the kind of thing you can do at pretty low cost. It just reduces the chances you're going to go down for a silly component failure. Now, component redundancy versus HADR. Every single one of these HADR technologies that I'm going to talk about has some failover duration. Some are shorter than others. So traditional failover clusters, you've got to move the cluster resources from one node to the other, and then you've got to start SQL Server on that new node, and all the databases on that new node have to go through crash recovery. And that's where keeping your VLF counts low is really, really important, because if you've got 20 or 30 or 50 databases on an instance and they all have high VLF counts, then it's going to take them a lot longer to go through crash recovery, and it's going to take longer to fail over from one node to another in your cluster. Availability groups and database mirroring, all you have to do there is a database property change. And so the failover is typically a lot faster, typically in the 5 to 10 second range, sometimes even less, depending on the load on your server. And of course, if you're using log shipping for your HA, which is really not the best idea in most cases, you're going to have to do a manual failover where you recover the database on the secondary server and then point your applications at it. And that's going to take, some time, although you can use some scripts to make it quicker and somewhat automate it. So, it's a lot better to avoid as many unplanned failovers as you can by making sure that nothing happens at the component level to cause it to fail over because you lost a hard drive, for example. And again, just take advantage of everything you can to try to make your server, your database server at least, more robust. And I used to work for a boss who, every time I would do a hardware quote, he would look at my quote and try to find something to knock off of it so he could save some money. So I learned that was his trick. So I would put something on there and sort of sandbag him that I didn't need. So then he would knock that off and felt like he had won the game. But people will quite often push back and say, well, what do you need 2 power supplies? Or what do you need 4 power supplies in this database server? And just keep in mind how important the database server is to your applications. So Windows failover clustering, it's been around for a long time, and people in the IT industry are usually very familiar with how it works. And you've got to have at least 2 nodes that are part of a Windows Server failover cluster. You've got to install the failover clustering feature on each one of your servers. And you typically have at least 2 nodes, but might have a lot more than that. And you might have just one instance on all these nodes, but it's a lot more common to have multiple instances installed on there. And the old terminology that makes Alan Hurt really angry is to talk about active-active or active-passive, but that's not really the best way to talk about it. It just comes down to how many nodes you have and how many instances you have installed on that entire cluster. And this requires shared storage, which is a big single point of failure. And no matter what your SAN vendor tells you about how many power supplies they have and how much redundancy they have, it is possible that that entire SAN might fail. It doesn't happen very often, but it is possible. And one alternative to that I think is going to be a lot more attractive in the future is using SMB 3.0 or newer file shares and using something called Storage Spaces Direct in Windows Server 2016. That's going to be a possible alternative to using a SAN for your shared storage. But anyways, regardless of whether you're doing that or not, one thing you can do is put tempdb, move it from your shared storage, and have it on each local node in your cluster. And that takes the load of tempdb off of your SAN and gives you much better performance. And as long as you make sure that the paths are the same on each node, it works quite well if you have local flash storage on each node for tempdb, assuming your workload requires that. And this gives you instance level high availability. So all of your databases now and all the databases you add later automatically are part of this. All your logins, all your agent jobs, your linked servers, everything is included in this. And then your applications are pointing at a virtual IP, so they don't really know or care what node you're running on. So it's really easy to set this up at an application level and maintain it. But the big weakness, again, is your failover time. It's quite often pretty common to see 60 to 90 seconds to fail over, but keeping your VLF counts under control is a big part of reducing your failover time. So that's Windows failover clustering. Now, always on availability groups, that is something that was, again, added in SQL Server 2012. It's an Enterprise Edition only feature, although they're going to have a very limited version of it in SQL Server 2016. And this lets you have one or more user databases that fail over together. And in order to do this, you have to have a Windows failover cluster instance, but you don't have to have shared storage. You just have to install the feature on each node in the cluster. And then each node can have its own local storage, or it can use shared storage. It's up to you how you want to set it up. And again, only Enterprise Edition does this until 2016 comes out later this year. And an availability database is just one of your databases that belongs in an availability group. And you have the primary database, which is your only read-write copy. You only get one of those. And then you have a secondary database that's read-only. And in SQL Server 2012, you could have 4 secondaries, but now you can have 8 in 2014. And all of your databases, when you do this, have to be in full recovery model at all times. So you can't be switching it to bulk log, for example. They have to be in full at all times. And this gives you pretty fast automatic failover if you set it up correctly. And it's also possible to offload some of your read-only activity to your secondary servers, but unfortunately you can't make any schema changes to the secondaries. So one thing that a lot of people have done for years is they will use transactional replication to have a reporting database, and they have that running on a different server, and they go in and add a bunch of indexes to it so the report queries run faster. And you can't do that with always on availability groups. The only thing you get is a small substitute for that is you get temporary statistics that are created in tempdb on the secondary node that helps a little bit, but it's not the same as having additional indexes. So if you thought you could get rid of transactional replication and use always on availability groups for reporting, that might not work. Now, database mirroring, it's been around since SQL Server 2005. It works really well. it has not been turned off, but it was deprecated in SQL Server 2012. So a lot of people are, oh, I shouldn't use that. It's deprecated. Well, I think that's the wrong way to look at it. If database mirroring makes sense for you, go ahead and use it. And when it finally gets turned off in the next version of SQL Server, it's still going to work on SQL Server 2016, which you might be using for 5 or 10 years. So don't be afraid of database mirroring just because it's deprecated. But anyways, with database mirroring, you've got a principal database and a mirror database that are on separate instances on separate servers. And only your user databases can be mirrored. You can't mirror system databases. And just like always on availability groups, they have to be in full recovery model at all times. And you've got synchronous mirroring and asynchronous mirroring. And asynchronous mirroring is only supported in Enterprise Edition. And if you want to get automatic failover with database mirroring, you have to use synchronous mode, and you have to have a separate witness instance to get automatic failover. And that witness instance can be running SQL Server Express Edition, and it's not really doing any work. It's just helping the mirror and the principal decide whether or not they have a quorum and whether it needs to initiate an automatic failover. That's all it's doing. And you get very fast automatic failover, but the main weakness with database mirroring is you only have one database at a time that's mirrored to just one location, and you can't really access the mirror copy. Now, if you have Enterprise Edition, you can do database snapshots on the mirror and run reports against that, but in real life that doesn't work really well, and I don't really recommend that you do that. So that's another weakness of old-fashioned database mirroring. But the nice thing about database mirroring is that you've got a separate copy of your data on each server, and that gives you another copy on top of whatever backups you have in place. And database mirroring is really easy to set up and maintain compared to always-on availability groups. So transactional replication. That just gives you a way of taking data on your publisher database and having multiple copies on subscriber databases. And if you want to, you can replicate the entire database or just individual tables or even portions of individual tables. And the source database is your publisher and the destination is the subscriber. And transactional replication uses a log reader agent that picks up all the write activity from the publisher. And so that's going to add a little bit more read IO workload to the log file. So you need to make sure you plan for that when you're configuring and designing your IO subsystem. And then you've got to worry about where your distribution database lives, whether it's going to be on the same server as your publisher or on a separate server. And that's going to require more licensing costs, but might give you better performance if you have a really heavy workload on your publisher. And thinking about how you do that is pretty important. And one nice thing about replication is you can have multiple subscribers and multiple locations. So once you've got the publishing going, you can have a lot of different subscribers that are used for different purposes. And it's quite often used to offload reporting activity from your main OLTP database. So a lot of people don't think that transactional replication is really an HA technology, but it can be used for that depending on what you're trying to protect. Remember, whether it's an individual table or the entire database you're trying to protect, you can possibly do that with transactional replication. Now, peer-to-peer replication gives you database level protection. And it's just another form of transactional replication that lets you have multiple writable copies of a database. And they can be in different data centers. And as you make changes in each one of your peer databases, they eventually get synchronized to all the other peer databases. And quite often people do this to try to get some scale out ability just using the built-in features of the product. And the HA part of it is just sort of a secondary bonus. Now, if you're going to do this, you might have to go in and make some changes to your application or your database. So for example, if you're just using identity columns for your primary key, you might have to go in and set up each database so that it has its own block of identity numbers so they don't overlap. Or you might have to do something which I don't like to do, which would be using a GUID for a primary key. And of course this requires Enterprise Edition to set this up and run it. And in my experience, I have not seen that many customers using peer-to-peer replication. I think a lot of people are afraid of it. It's a little bit complicated, but it's been out there for a number of years, and it's another thing you might be able to do. Then finally, we have log shipping. And this gives you database level protection, and you can have multiple copies of your principal database in multiple locations. Now you've got to be in full recovery model just like most of these other technologies. And if you do have a failure, you're going to have to go in and do some work. And the main thing to do is just to restore the database with recovery on your secondary copy, and then make sure your application is pointing at that other server. And it's possible to lose some data with log shipping. It depends how often you're taking log backups and whether or not that last log backup was actually copied over and applied on the secondary before you actually restored it and brought it online. And so log shipping is usually a lot more commonly used for disaster recovery purposes, but it's also pretty handy to use it to protect against user error. So you could have multiple log ship copies, and then on one of them you might decide, well, I'm going to put in a 4-hour delay. So I'm not going to restore the logs on this one server until 4 hours have gone by, and that's a rolling window. So that way if somebody deletes a bunch of data, you've got a 4-hour window before that data deletion moves to the DR server. So you can go and get your data from there if you're not using something like SAN level snapshots or database snapshots to protect against that sort of thing. And most of these other things, like if you're using database mirroring for HA, you could also use log shipping at the same time for DR purposes. And the nice thing about log shipping is it doesn't add any extra overhead to your primary database, because you're having to take transaction log backups anyways. So all you're doing with log shipping is copying them somewhere else and then restoring them somewhere else, and then none of that affects the primary database, like some of these other things like always on availability groups put extra load on your primary read-write database. So here's just sort of a chart. And by the way, you'll all get a PDF version of this deck. But anyways, here's a chart that just sort of highlights some of the more important HA features by edition. And there's things that you get in Enterprise Edition that I haven't really talked about that much. So for example, you get partial database availability, which means that when the primary file group comes online, the database is online and you can be working on restoring the other file groups. You get backup compression in Enterprise and Standard Edition. Database snapshots are Enterprise Edition only. Online index operations are Enterprise Edition only, but most of the rest of these are available in everything. The main exception is always on availability groups, which were not in Standard Edition, and then they're going to have a very limited version in Standard Edition in SQL Server 2016 that just lets you have one database in your group and one secondary copy, so it's going to be very similar to database mirroring, which they really needed to do that because when they deprecated database mirroring, they needed to give you a substitute, so you had something besides just log shipping in Standard Edition. So planning a disaster recovery strategy. What you want to do here is making sure that you've got a strategy that's going to handle what you think is most likely to occur, and that you have a specific data loss SLA for your RPO and a downtime SLA for your RTO, and knowing what has to be restored first, what applications are the most important, and what databases have to be worked on first. You shouldn't be making this up on the fly as a DBA. You should have a plan for this. Now, a good disaster recovery plan, you want your most senior people to put it together and try to come up with the most robust plan they can, but then you want to make sure the most junior person on your staff can actually execute the plan, because they're the ones who are usually on duty late at night or on the weekends or on a holiday, because your most senior people might not be on call or just might not be available. And you might even want to try to write this so that if somebody else besides a DBA could actually do it, so your network admin or your on-call server admin or even somebody at the NOC could actually start doing this if they had to, if nobody else was available. And this plan needs to be very comprehensive and complete. You can't just say, well, restore the database from the backups. That's not going to be good enough for most people. They're going to have steps on, okay, here's where the backups are located, and here's how you figure out what order to do it in, and here's a sample script that you could use to get started on this. And you also need to think about the human factors. If there's a widespread disaster, so if your entire city is flooded, most likely, most of your employees are more worried about their houses and their families, and they're not quite as worried about rushing into work to try to get your application back online. So keep that in mind, depending on what might happen. Would you handle that? You know, where Jonathan used to work at Outback Steakhouse, they used to have a plan where they would put all the key people on a plane with their families, and they would fly them to another city. And it's okay, now we're doing a practice DR scenario. And planning like that is really important in real life, depending on what scenario you're trying to protect against. And again, if you don't actually ever test your DR plan, it's probably not going to work very well the first time you try it for real. And if you do practice it, you want to make sure that whatever problems you run into, like, hey, wait a minute, we didn't have any keys to install Windows with, or no product keys for SQL Server, or we didn't have the binaries available to us. Whatever you run into as you practice it, you update the plan so the plan gets better and better over time. So other things to think about when you're doing DR planning: what problems that you might run into as you're going through your DR scenario. What if the server was damaged by water or fire? What are you going to do? Do you have some spare servers? If you want to order a new server from Dell, can you get it in 4 hours or 4 weeks? Can you rent a server? What if the SAN has been physically damaged? What would you do? What if there's no power at the data center? Do you have some backup generators of your own besides what the data center has? Can you move these someplace else temporarily and give them power and network connectivity? What if the entire data center is gone? What would you do? Do you have some spare servers available somewhere else? Do you have a secondary data center with cold servers just sitting there? Do you have off-site backups, and where are they stored, and how do you get them back? What if the backups are corrupt? Do you have more than one copy? And then what if your key people who know how to do all this stuff aren't available? Does anybody else know how to do any of this stuff? All right, DR planning people issues. When something happens, do you have like a call tree? Who gets notified first, and who starts making the calls? Who's actually in charge? And who is sort of the stakeholder or sponsor who can resolve any kind of disputes about we should do this first or we should do that first? And who has to be kept informed as you're working on this? And another one that's really, really important is who makes the call to authorize a failover? So, a war story from when I worked at Avalara several years ago. We had a problem where we had failover clustering in our main data center, and then we used database mirroring to go to a secondary data center. And what happened to us one day was that there was a problem with a network switch that lost its power supply. So we lost connectivity to our database server, and it wasn't immediately evident what the problem was. We just knew that we couldn't get to this database server. And what Avalara does, they do online tax calculations for retailers. So all their POS systems are tied into this. And so they really were very, very sensitive to downtime. So after about 60 seconds of not being able to talk to the main database server, we ended up failing over to the secondary data center. And doing that was a really big deal. And it was really hard to get back to the main data center. But my point of telling this war story is that you want to have somebody who makes the call, and you want to have a policy in place for how long do you spend troubleshooting the problem before you try to fail over. Because it could have been, and we actually figured it out just a few minutes later what the problem was, but by then we'd already failed over. And so who makes that call? Do you fail over too soon, or do you wait too long? And if you're the DBA making that decision, you're going to get in trouble no matter what you do. So you want to make sure there's a plan and a policy in place. Okay, we're not going to spend more than 90 seconds troubleshooting before we fail over to the DR site, for example. Don't make it up on the fly. And then also you want to make sure you understand what other teams have to be involved to make this actually work. Can you do this all yourself as the DBA, or do you have network people and other people, developers and QA people involved to make sure that everything actually works after you fail over? I mean, if it's a web application, the DBA might be able to go onto the website and make sure that it seems to be working, do some light smoke testing, but they're not going to be as good as the developers or the QA people who know how to fully test the application. All right, so HADR testing. You want to make sure that you actually test your HADR solution before you go into production with different failures that you might run into. So, for example, what happens if you just walk up to a server and yank out one of the drives or unplug the server? Or what happens if you drop a table or truncate the data in a table? Does your HADR solution handle that gracefully? What happens if you unplug a network cable? And quite often, this sort of thing is called chaos monkey testing. And so one thing that sometimes you do, we did this at Avalara, is we set up all of our stuff, and then we had a receptionist from the corporate headquarters go into the data center, and we just told her, well, just go pick a cable and unplug it, or do whatever you want. And then we would figure out, can we handle that, or did everything come crashing down? And by doing that, I guarantee you're going to find things you didn't think of, or you're going to figure out that, hey, when we lose the data drive, it doesn't cause an automatic failover like we thought it did. So we have to put in something in place to detect that and force a failover. So doing that is really, really important. It's also important that you actually try practicing a bare metal install. So what happens if you have to stand up a new server and get everything reinstalled and reconfigured on it? So racking the server and cabling it, installing and patching Windows and installing and patching SQL Server. Can you actually do that? And how long does it take you? And then try doing a full restore from your backups. A lot of people don't ever really do that until it's an actual crisis, and then they have a lot of problems and it takes them longer than it otherwise would have. And if you can't meet your RTO SLA requirements when you go through and practice this, you need to push back and say, wait a minute, even though we agreed to a 2-hour RTO, as we've gone and practiced this, we figured out we just can't do it because of these reasons. So maybe they'll ease that RTO, or maybe they'll give you some more money so you can get the equipment you need to make this work. And make sure that they know that before you go into production. So that way when something happens, they're not surprised and you don't look like you didn't know what you were doing. So these are the kind of things you need to think about to have a really effective HADR strategy. And unfortunately, so many organizations don't do very much of this. And then they have a problem, and then they get very interested in HADR later after they've had the disaster. So here's just some resources for reading more about this. There's a really good white paper, even though it's SQL Server 2008. It talks about all these concepts very well. Of course, it doesn't include always-on availability groups, but it explains all the weaknesses and strengths of the different HADR technologies that are available in SQL Server. And then the next white paper is a very good resource. And then for more detailed coverage of always-on availability groups, the third one is a good resource. So finally, just to summarize, this is just a lot more than saying, okay, I think always-on availability groups is a really cool technology. That's going to be my fix for this problem. There's a lot more to it than that. And the most basic thing is make sure you understand your RPO and RTO, and that you and the business have agreed on that, so they don't have an unrealistic expectation of what you can do. And make sure that you and your business both understand your budget and infrastructure limitations. They may want a 0 RPO, but unless you have a lot of money and a lot of infrastructure, that's really, really difficult to do. And then finally, no matter what, make sure you have a good backup and restore strategy. Because I've had so many managers over the years come to me and say just stupid things like, well, we're using RAID 5 to protect our databases, so we don't need to do backups anymore. Or we're using database mirroring, so we don't need to do backups. Don't let anybody talk you out of doing backups, and then make sure that you're actually testing the backups and restoring them to make sure they work. And then finally, keep in mind that you can combine these different HADR features. So you don't have to say, well, we're just going to use failover clustering and that's it. You could use failover clustering for local HADR, and you could database mirror to another data center, for example. Or you could use database mirroring and log ship to another data center. So you can combine these to try to get the most robust solution that meets your RPO and RTO goals. So that's it. I think I've got some time left for some questions, if there are any.
Anybody have any questions? No questions.
No questions. All right, well, I appreciate you listening to this, and if you have any questions later, you can send me an email.
I've got a
Go ahead.
question. I was just talking to Kim about this earlier. I have a 3-node availability group. 2 are synchronous and 1's asynchronous. And we have a vendor upgrade software that we'll be doing later this year where they really do a lot of work on the database side with changing columns, adding indexes, and also affecting the data. And my old system, we were doing SAN replication, and it got to the point where it couldn't keep up and we had to split the replicas. So we haven't done any testing